This just in some breaking news. As we all know, we've been anticipating for an answer from the College Board in regards to what will happen to our AP exams this year. First and foremost, I want to give recognition to John for being our A+ reporter and sending me information when it was released. According to the College Board website, the AP exams will be 45 free response question exams that will be done at home. Students can choose between two dates to take the exam. However, do not choose a date and wait for the instructions of your teachers. These dates will be announced on Friday, April 3rd. These exams could be done on the computers, tablets, or phones. Students will have the ability to take a picture and submit their handwritten work. College Board is currently working with partners to invest in tools that students might need to complete the exams. College Board also announced that due to this change, has been some modifications to what units will be tested on the exam. So for AP Statistics, they are testing on units 1 through 7, which refers to our units 1 through 8 and part of 9. So that means we're almost done. College Board also made the announcements that they will be offering free online review videos for the exam, but it's to be determined when these videos will be released. The organization also written that students who have already registered for the exam can choose to cancel at no charge, though I do not encourage this. If for some reason you feel the need to cancel, whether that be a money issue or you feel not as prepared, you might want to rethink your options. I suggest possibly reaching out and talking to me and or your other AP teachers for advice. That is all the important news for now. If you would like to read more about the details of the AP exam, I have posted a link on Google Classroom for you to do so. Now on to our next segment of the show. All right, y'all, so we're gonna go ahead and do an extension lesson on lesson 1. This is for you to get more practice on calculating a z-score given certain proportions. I know that we went over it real briefly in the last unit or last lesson, and being able to calculate the z-scores is really important for you to be able to calculate your probabilities. So I have 3 problems that I'm gonna go over with y'all. And then in the very last problem, you're going to do it on your own and then complete the check for understanding in this video at the very end. So we're going to start with number 1. Any basketball fan knows that Shaquille O'Neal, one of the NBA's most dominant centers of the last 20 years, always had a difficulty shooting free throws. Over the course of his career, his overall made free throw percentage is 53.3%. During one off-season, Shaq had been working with an assistant coach on his free throw technique. During the next season, a simple random sample showed that Shaq made 26 of 39 free throws. What's the probability that he actually improved on his free throw percentage? So, in order to calculate a z-score using proportions, there's a few things that we need. We need P naught, which is the probability that is the probability that was claimed. So in this case, Shaq, in his previous season, Shaq claimed that he had a 53.3% free throw percentage, right? P hat is always our sample proportion. So in this case, P hat is given by doing 26 divided by our sample size. And I'm going to do these in different colors so that you can see what's happening. So P hat, which I'm going to highlight in pink, P hat is given as 26 over 39, and 39 is our sample size, 26 is the number of successes that he had. We also need to calculate our standard deviation for our sample proportion. So standard deviation is the square root of P naught times 1 minus P naught over our sample size.
So that is the square root of 0.533 times 0.467 divided by 39. And once we do that, we get 0.08. And I'm going to highlight that in green so we can plug it into our equation. So our equation is z equals p hat minus p naught over standard deviation. So p hat is 66.7%. P naught was 53.3%. So we're going to do 0.667 minus 0.533 divided by 0.08. Okay, so I'm going to go ahead and draw my curve to help me understand which type of probability I'm going to be doing. So here is 53.3%, and we're trying to see what is the probability that he actually improved on his free throw score percentage, meaning we're looking at everything to the right because improving means that his free throw percentage should have increased. So the probability of z being greater than, so after I calculate this, this becomes 1.68. Probability of z being bigger than 1.68 is equal to 1 minus the probability of z less than 1.68. Okay, and here's why. So I'm going to take out my z-score table, and notice that my z-score table is shaded to the left, right? But in our drawing, we shade it to the right. So we're going to take 1 minus whatever the probability that we get. So our probability was 1.67. And 1.67, if I look at it, is this row right here. Or sorry, our z-score was 1.68. So we're looking at this row. And 1.68 is right here. Okay. So if I go back to my work, I'm doing 1 minus 0.9533, which means 0.0465. So that what this is telling me is that there's a 4.65% chance of him improving his free throws percentage to be 66.7% or more. Number 2. A drug manufacturer claims that fewer than 10% of patients who take its new drug for treating illness will experience nausea. In a random sample of 300 patients, 21 experienced nausea. What is the probability that less than 10% of patients will experience nausea? So I'm going to go ahead and highlight some of the information that I know. I know that my P naught is going to be 10% because that's what it was claimed, right? That's what the company claims. I'm going to highlight my sample size, which is 300, and my number of success is 21. So that means that P naught is 10%. I'm going to write this in a decimal form. 0.1. P hat is 21 over 300, which is 0.07. And then I'm going to calculate my standard deviation, which again is the square root of P naught times 1 minus P naught over n. So that's the square root of 0.1 times 0.9 over 300. And that means I have a standard deviation of 0.017. So z equals P naught, z equals P hat minus P naught over standard deviation. So that's 0.07 minus 0.10 divided by 0.017, which is negative 1.73. So if I were to shade my curve, it says that what is the probability that less than 10% of patients will experience nausea? So here is 10%. And if we're trying to find a probability that less than 10% of the patients will experience nausea, Here is 7%, and we're going to shade to the left. So we're trying to find P of Z less than negative 1.73, which, if we look into our chart, taking out our chart, negative 1.73 is on the negative side. We're here. And so this is 0, 1, 2, and this is 3. So the probability of this happening is 0.0418. So we have a 4.2% chance that 7% or less will experience nausea. Okay. I'd like for you to pause right here, and I want you to try number 3 on your own and then watch the video to see if you got the correct answer. So let's get started. As you may know, this year is an important year for many reasons. One reason is the United States is completing their census right now. The census is important as this is how we figure out how many people live in each state. It allows for us to figure out a lot of political things like number of electoral college votes each state gets and more. In a previous official census, 8% of couples living together are not married. A researcher believes that in 2020, the percentage of couples living together that are not married will be different from the previous. He took a random sample of 400 and found that 9.5% of couples living together are not married. What is the probability that this year's census will have a different proportion of unmarried couples? That means we're doing a P does not equal P naught. So this is a two-tailed test. Okay. And remember that for a two-tailed test, whatever our probability is, we times it by 2. So let's go ahead and annotate this for some important information. We know that P naught, let's start with P naught. We know that P naught is 8%. That's what we're testing against. It was claimed in the previous census, 8% of couples live together are not married. Our P hat is what we found in our sample. And in this case, that's 9.5. And our sample size is 400. Okay. So P naught is 8%, so that is 0.08. P hat is 0.095. And our sigma of our proportions is P naught times 1 minus P naught over N. So that is 0.08 times 0.92 all over 300. No, all over 400. And putting this into our calculator, we should get 0.136. So Z equals P hat minus P naught all over standard deviation. So 0.095 minus 0.08 all over 0.136, which is 0.11. Now let's go ahead and draw this. Okay. We know that this is a two-tailed test, right? So I'm going to draw it over here where I have a more room. We know that Z of 0 is right in the middle. Because this is a two-tailed test, we have to look at both Z equals to positive and negative 0.11. So I'm going to shade both sides. Okay. Then what you're going to do is you're trying to find P of Z less than negative 0.11 and P of Z greater than 0.11. Okay, so that means that we're going to open up our Z table. We're only going to look at the negative part of it. Okay, we're going to look at negative 0.11, which is right here. Right? So here's 0 and here's 1. So, and then what we're going to do with that is we're going to multiply it by 2. So P of Z was just going to write it up here. So what this means is 0.4562 times 2, which means 91.24%. So there's a 91.24% chance that we would get a sample proportion of 9.5% of couples living together that are not married. Okay. Next. For the check for understanding, I want you to go ahead and finish this problem first, submit your answers, and then you can go ahead and get your answer, check if you got it correct. Okay? So, in a survey of 1,273 adults, 52% said that it is not morally wrong to change the genetic makeup of human cells. Part A, what type of tests would you perform to test this hypothesis? Since we're looking at percentages, this would be a 1 proportion z-test. Okay, I believe there are no t-tests for proportion. T-tests are only for means. If we're doing proportions, it must be a z-test, because usually you know the population proportion. B says, in a random survey of 500 adults, 200 adults says that it is not morally wrong to change the genetic makeup of human cells. What is the probability of this sample proportion occurring? Meaning, what's the probability that the proportion of adults that think it's not morally wrong to change the genetic makeup of human is actually less than 52%? So, I know that P naught is 52%, and I'm going to rewrite this as a decimal, 0.52, and P hat is 200 over 500. Okay. I know that my standard deviation is equal to P naught times 1 minus P naught over N. So that's the square root of 0.52 times 0.48 over 500. And that gives me a standard deviation of 0.022. Now Z equals P hat minus P naught over standard deviation. So 200 over 500 is 0.4. So 0.4 minus 0.52 over 0.022 gives me a z-score of negative 5.38. Now, if we look at our z-score table, right, the highest it goes up to is negative 3.4. What does that tell us? That tells us that this z-score, because it's not even on the z-score table, we're going to assume that P is so small that it's approximately 0%. So that what this means in this context is that there's a 0% chance that this sample proportion would actually occur. Okay. Now that you've finished this and completed your check for understanding, I'm asking you to go ahead and do the Khan Academy practices. That's going to help you get some more practice on calculating the z-score for proportions. If you have any questions, please make sure that you ask me by emailing, texting, or calling me. I also have office hours every day from Monday through Friday at 2:15 to 3:15 p.m. for AP Stats only. Hope y'all have a wonderful day.